Okay, it feels like we're going backwards because we were started in chapter 10, but it's just kind of like how we want to present things in pre-calc this year. So let's go into chapter 1. 1.1, the title is for us is Graphs and Graphing Utilities, so I'm going to show you some things on the graphing calculators today, so make sure you have access to that. And we're going to begin our study, or our discussion rather, of chapter 1.1, talking about this thing called the coordinate plane. Raise your hand if you have ever seen or talked about a coordinate plane before. Let the record show for the video that almost everybody's hand is up. Okay, let me ask you a question then. What is a coordinate plane? It's the ceiling with a fly? What does that even mean?
That's how it was created. When the guy was laying on his bed and he looked up and he was like, how am I supposed to figure out where the fly is? Okay, stop.
Oh, I've never heard that story before. That's interesting.
That's like how, that's actually...
No, that's really cool. I like it. I'd see where you're going with it, but I never heard it. Yes?
It's like a graph or a labeled plane that has like quadrants.
Okay, yeah, it has quadrants, but like more simplistically, if you just take a look at, say, the x-axis and you consider nothing else, what is the x-axis? It's, think about back in like third grade, a number line. That's it. That's the point I was trying to make, okay? A coordinate plane. Did you say that?
She said it like 5 times.
I'm sorry, dude. I didn't hear you. Yeah, the coordinate plane is just the intersection of two number lines. And where do they intersect at?
At the origin.
At the origin, which is called 0, 0, right? We label that point 0, 0. And by intersecting two coordinate planes, we break up the graph, or so to speak, the coordinate plane into 4 different quadrants, right? Quadrant 1 is up there in the top right, and then it goes counterclockwise all the way to quadrant number 4. So you got 1, 2, 3, and 4. You've seen all this before, right? Okay. What else could we ask about this the coordinate plane here? What does it allow us to do? What does it allow us to do? Graph lines. Do they have to be lines? Parabolas. They allow us to graph points, right? And the points can come from many different functions or equations and so on and so forth. But they allow us to graph points. So that brings us into box number 2, okay? So box number 1 was just a conversation. Box number 2 is actually doing something with the coordinate plane. So what we're going to do is we're going to plot the ordered pairs and we're going to name the quadrant in which they end up in. And I'm going to teach you how to do it in a way that makes a lot of sense. And the language that goes along with it. So if I'm going to plot point A, bless you, then what I'm going to do is I'm going to say, okay, from the origin, I'm going to go 2 units to the left and 1 unit down. I'll say that again. So this is how I'm going to describe where to go to plot point A. It's located at -2, -1. So from the origin, I'm going to go 2 units left and 1 unit down. So from the origin, 2 left, 1 down, put a dot, and that's called point A. So far, so good? Yeah, put these on your page as well. So why is it important to state from the origin? Because you have to start there, right? That's where we all start at 0, 0. Okay, good. So point B, how would you describe it the same way? From... Okay, so here's how we're going to say it. From the origin, we're going to go 3 units to the right and 2 units down. 3 units to the right and 2 units down, and put a point. That's point B. Okay, point C. From the origin, we go 5 units right and 3 units up. There you go. 5 units right and 3 units up. That's point C. Okay. Point D. From the origin, we go 0 units left or right, and we go 1 unit up. Very good. And that's point D. Very good. And then point E. That's a -2, by the way. What do we do for point E? From the origin, go left 2 units, and that is point E. Okay, let's label all these now. Point A, what quadrant is that in?
3.
Quadrant 3, so very good. Put that in quadrant 3. Point B, where's that one?
4.
Quadrant 4. Natalie knows these. Quadrant, or point C, what quadrant?
1.
Everyone, yeah, quadrant 1, very good. Okay, point D. Yeah, it's not in a quadrant, right? Where? It's on the y-axis, very good. So we say it's on the y-axis. Okay, similarly, what about point E? It's on the x-axis. Very good. Okay, so the first thing that we are able to do, and this should be reviewed for many of you, is that we should be able to plot ordered pairs in a coordinate plane. The equation that we're being asked to graph is the equation y equals 10 minus 2x squared. And then they want specific values of x. They want us to use the values of -2, -1, 0, 1, and 2. So in your homework tonight, you're going to be asked a similar question. They're going to say, okay, use these points to graph this equation. Okay? And this is how I want you to do it. I'm going to model it for you right now. We're going to make a table. Okay, we're going to make an x column. And we're going to plug in the x values that were given to us. And they want us to use -2, -1, 0, 1, and 2. That's what they want us to use. Okay, what do we do with those x values? Yeah, we plug them into the equation, right? And the equation that we've been given is y equals 10 minus 2 times x squared. Why did I write it in parentheses right now, just now?
So when we put it in our calculator,
Okay.
it raises the symbol and not just
Yeah, to remind you that that's what's going to be changing, right? We're going to be using the values that we've been given to get new values out of that. And then I'm going to make another column, which is going to be an x and a y ordered pair, so I can see exactly where to plot those points. Okay? We're going to do the first one by hand, and then we're going to do the other 4 points using the calculator. And I want you to be able to use the calculator. So let's do this one by hand. If I plug in a -2, let's see here. What's -2 squared? 4. What is 2 times 4? 8. And then what's 10 minus the 8? 2. So I'm getting a value of 2 here. So what would be the ordered pair that would coincide with this? -2, -2. Very good. And we're going to stop right there, because I wouldn't want to do all of these for all those points. After all, I could give you many more points than that. We're going to use the calculator, and I'm going to show you how to use the calculator to accomplish all this stuff. So take your calculator out wherever it happens to be. All right. And I would like you to go to the y equals button. And the y equals button is over here in the top left-hand corner. Now, if there is an equation in here, then you can go ahead and clear it out just by pushing clear. The little subscripts here, the 1, the 2, the 3, and the 4, those are all just different equations you can plug into the calculator. So you can plug up to about 9 or 10, depending on what calculator you're using. So we're going to enter in the equation 10 minus 2x squared. So go ahead and do that right now. We're going to go 10. We're going to use the minus sign. And then we're going to go 2. Now the x button is the variable button. It's the button that's to the right of the green alpha button. So x. And then we want to square that value. So we can actually put the five buttons down on the left-hand side. That's a squared button right there. You can also do caret 2 if you'd like. That's an extra keystroke, but yeah, you can do that as well. So you should have something that looks like this, and that's all I want you to do right now. Okay, is everyone there with me? Put your hands up if you're with me. Good. Okay, help your neighbor out. Cat needs help. So, ladies and gentlemen, from here, what we want to do is we want to use the calculator to get these values out that we've been given for the x. Does that make sense? The way that we do that is we use the table feature. Okay, and here's how you use the table feature. The table is up above where it says graph. And to access it, you push the blue second button, and then you push graph. That gives us a table. Now, your table might be in a different location than my table. And what I mean by that is your numbers here on the x might look different than my numbers here on the x. That's because we're just in different spots. If you notice, if you just move your cursor up and down, it should give you the table increments. There is a way to change your table values, and we're going to do that right now together to make sure that we're all seeing the same thing. The way that we do that is we're going to go to second, and we're going to now push the window function, because up above it, it says table set. All right, is everyone still following along with me today? Here, this is the table setup window, so check it out. You can start your table at any location for x value that you want. And since our first x value is a negative 2, I'm going to start mine at negative 2. And the way that I do that is I just enter in negative 2. Not the minus sign, the little negative button below the 3, negative 2. Okay, the next line down says triangle TBL. That stands for delta table. That means the increments in which the x values change. And since our x values are negative 2, negative 1, 0, 1, and 2, they're changing by a value of 1, so we're going to keep it as 1. Okay? Now you also have this option of independent and auto ask and dependent auto and ask. That just means we want the calculator to generate the values, not us asking the calculator for values. So we're going to keep those both as auto. Now, when we go back together as a class and go second table, we should all be in the same spot. Are we all in the same spot? Okay, now we can use this to our advantage here, right? So I'm going to close my table down because I can't write and see the table at the same time, but help me out, okay? At negative 1, what's our value? What's our output? 8. At 0, our output is 10. I know that one. At 1, it's 8. At 2, it's 2. That doesn't look like an 8 very much. Okay, let's do this. Okay, then the ordered pairs that we would get would be negative 1, 8, 0, 10, 1, 8, and 2, and 2. Awesome. Now that we have these points, we're going to graph these points, okay? So let's take a moment and consider where we should be graphing. Where is negative 2, 2? What quadrant is that in?
That's the second.
That's quadrant number 2. What about negative 1, 8?
Question 2.
Also quadrant 2. What about 0, 10?
The
That's the y-axis. What about 1, 8?
the first.
That's quadrant number 1, right? And then what about 2, 2?
That's also the first question.
Also the first quadrant. So I really just need to highlight quadrant 2 and quadrant 1, right? So that would look something kind of like this. So if you take a moment and actually plan out what your graph should look like, it ends up being a lot better. So here's the x-axis, here's the y-axis, and this is what you guys should be doing on your homework. Notice how the increments are actually kind of to scale, right? And how high should I be going up here? What's the highest one that I need? 10. I need 10, exactly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So there's my 10.
Would you like us to actually draw it out?
Yep, do exactly as I'm doing here. I'm modeling it for you.
But I'm saying, what if we get a value of 50? Do you want us to?
Well, no, not 50. You can scale it out, yeah. Just do what's appropriate. Okay, now that we have all this, we're going to plot each and every point on there really quickly. So negative 2, 2, that point would be there. Negative 1, 8, that point would be there. 0, 10, 1, 8, and 2, 2. Anybody know what this actually looks like? Looks like a parabola. Very good. So something like that. Okay? Now, you can then use your calculator to check to make sure that indeed that graph is the one that we should have been graphing. And the way that we do that is just by pushing the graph button. Okay? Now, I have a couple of settings in my graph that show me the grid and the scale. You might not have those settings, and that's okay if you don't.
Wow, that's cool.
Okay?
I love parabolas. Wait, how do we do that?
Okay. You can change the settings in here by clicking second format, which is the zoom button, and you have all of these options for you. I'm not going to go over all of them. There's way too many. Most people just keep the grid off, actually, to be honest with you. And most people keep the axes labeled off as well. So the standard one should look something like this.
So how do we graph it?
Underneath second zoom, which is the format. All right, ladies and gentlemen, you have the ability to move this window around. Okay, what I mean by that, so if you take a look at what our graph looked like right here, notice that it's just from negative 2 to 2 and then up to 10. You have the ability to move the window around by going to the window button. That button is here. If you change these settings, then it will change the actual window of the graph. So if I made this, let's say, negative 2, my lowest x value of negative 2, and my highest x value of positive 2, and my scale of 1s, then I'm only going to see on the x-axis from negative 2 to 2. Likewise for the y's. My lowest y value, if I make it 0, and my highest y value, if I make it 10 like it is on my picture, and then I hit graph, I would see a much different picture than everybody else, okay? So, ladies and gentlemen, what I'm about to say is very important. At any moment in time, if your scale is not the normal 10 by 10 grid, 90% of the time, this will solve your graphing issues. If you hit the zoom 6 is the standard window. It automatically brings you back. It's like the home button on an iPhone. It brings you back to where you should start off, okay? It's the same thing. So at any moment in time, if your graph is being funky or not participating correctly, hit zoom and then the number 6. It's the zoom standard window, okay? Does that make sense? Okay, this is a U try, but many of you might not know where the absolute value button is on your calculator. I'm going to tell you where it is right now. When you go to y equals, from the y equals screen, we're going to clear this out. I'm going to plug in an absolute value of x. The way that you get there is from this screen, hit math, and go over to the number tab. And it's the very first one, ABS, abs. That stands for absolute value. If you push enter from here, it brings you back to the y equals button. From there, you can plug in your variable, which is x. And then you need to get outside the absolute value bar symbol and then subtract 6. That's the proper way to enter it into your calculator. So what was the equation again that I gave you guys?
Y equals the absolute value of x.
Y equals the absolute value of x, and then it was minus 6. Good. So your graph should look kind of like this, right?
Cartesian plane.
Right. And then, of course, then if we give you the table of values, you should see all these values. I gave you, what, -4, -3? So you should have had -3, -2, -4, so on and so forth, and that brings 0. So your graph should look like this. Is that correct? All right, good. Notice it's not a parabola. Right? This is called fluid math. Yeah. That's pretty cool. Okay, so back over here, right? Everyone, this is 5. 4 was the U try. So here's a 5. Here's what I want you to do. Best of your ability, copy this quick little graph onto your page as best as you can. Make a nice little sketch. Ready, set, go. Okay, here's your task. Now that you have this picture, here is your task. I'm just going to tell you what the task is, okay? I want you to circle all the intercepts that you see, and I want you to label those intercepts. That's what I'd like you to do. Notice I'm not telling you what intercepts are. I want to see what you know. So, Kat, tell me, where did you circle? I'm going to do this in blue. What did you circle?
I circled 0, 4.
0, 4. Okay.
2, 0.
2, 0, and a -2, 0. So this was -2, 0. And then you circled 2, 0. And then you also circled 0, 4. Good. How did you label them?
I just did A, B, C. I don't know.
Oh, you should A, B, and C. So what do we call these two over here? This one and that one. What do we call those ones? Those are x-intercepts. Why do we call those x-intercepts? Because they intercept the x-axis, okay? And what do we call this other one up here? The y-intercept. Why do we call it that? Because it crosses the y-axis, okay? What do you notice about every single point that is labeled as an intercept? What do you notice? It has a 0 in it, right? That's a good giveaway that it has a 0. In fact, we use that later on to help us with identifying these intercepts. Okay, so there are both x and y intercepts. Sometimes there are neither of the two. Well, there's always one kind, right? Unless they're talking about a function. So for the last box here, the whole point about graphing is to put information onto a picture and then to get information out of that picture, okay? So right now, here's the situation. It says, at noon, comma, you begin to breathe in. That's all that they tell you, okay? This comes out of the book. I thought this was a very interesting question. And you have 4 graphs in front of you. You have graph A, B, C, and D, all right? Your task right now is to decide which one of these graphs, A, B, C, or D, could depict the scenario of at noon you breathe in. I don't want to answer right now, okay? I want you to answer. I'm going to ask you a different question. What 2 things are we comparing against each other? What 2 things are we comparing against each other? Time when? Time afternoon compared to volume of air in your lungs. So we are comparing 2 quantities, time and volume of air. All right? So right now, I want you to think about for 10 seconds by yourself quietly inside your own brain which one you would pick and why. Okay, now here's what I want you to do. Turn to someone next to you and quietly have a discussion about which one you picked and why. Okay?